All right, so just going to talk briefly about composition. Just like to summarize, hopefully, some of the things that you're developing through the first exploration and practice. So basically, composition of functions is just plugging one function into another function. And so we want to be sort of flexible with this. And the reason we might want to do this is because many times there are multiple things that depend on each other, and you'll see some examples of that later on, like, oh, maybe the altitude depends on how fast you're moving upwards, and the temperature depends on the altitude, and the rate that you're burning fuel in your hot air balloon depends on the temperature. So many things sort of depend on each other. And so you can plug in one thing, get another thing, get another thing, get another thing, get another thing. So it's this sort of chain of plugging in values. So we'll get to that a little bit later. But here, let's just practice a couple things. So first of all, we can have something like f of g of 3. Okay, and I invite you to take some notes on this if you want to. F of g of 3 means plug 3 into g, then plug that result into f. So if I were to map this out visually, it'd say, take 3, plug it into the g function, get something out, call it g of 3, then take that value and plug it into the f function, and then get out f of g of 3. So that's sort of the map of how it goes, right? You start at the inside and you go to the outside. You're plugging it into g, getting g of 3, then plugging that into f, and then getting out f of g of 3. So let's find g of 3. All right, well, g of 3 is 9 plus 15 plus 10. That's 25 plus 9, which is 34. Now we're going to take that value and we're going to plug it into f. So what's f of 34? Okay, again, since g of 3 is 34, we can now plug 34 into f. And f of 34 should be 2 times 34 minus 7. So 2 times 34 is 68 minus 7 is 61. Okay, so that is f of g of 3. It's 61. Okay, I'm going to erase some of this, or maybe not. Let's just try one more. Let's try g of f of 2. Okay, so if we were thinking about g of f of 2, basically what we're doing is we're plugging 2 into f, then plugging that result into g. So 2 gets plugged into the f function machine, and out comes f of 2. Then we're going to take that and plug it. This can be a circle, I guess, if I'm following my stuff from above. And then I'm going to take f of 2 and plug it into g. And so I'm going to get then, let's see here, that's going to be the g function, and out is going to come g of f of 2. So if I plug 2 into f, f of 2 is going to give me, let's see here, f of 2, 2 times 2 is 4 minus 7 is negative 3. And then if I plug negative 3 into g, I will get out, well, 9 minus 15 plus 10, so 9 minus 5, which is 4. Okay, so I would end up with 4. Okay. And so basically, we can just plug things in, into one function and then plug it into the other function. However, many times we actually want to get a formula for the actual function. So instead of just plugging in numbers where we can just plug it into one function and then plug it into the other, what we would like to do is actually get a formula for f of g of x, f of g of x. So if we actually want a formula, that means we have to take all of this function and plug it in and replace it for x in f of x, right? Basically, I like to make a template. F of whatever I want is equal to 2 times whatever I want minus 7. Well, instead of plugging in x or a specific number, in this case, I now want to plug in g of x. So I'm actually going to plug in x squared plus 5x plus 10. So I'm actually plugging my entire function in here. And since that is the same as g of x, I can write f of g of x is equal to 2 times x squared plus 5x plus 10 minus 7. So I've plugged my entire function in here. If I wanted to simplify that, I would get 2x squared plus 10x, then that's going to be plus 20 minus 7, which would be plus 13. So this is a simplified formula for the composition f of g, so f of g of x. And I forget what value we plugged in, but I think we plugged in 3. So if we wanted to check and see if this works, we could plug in, f of g of 3. That would be 2 times 9 plus 30 plus 13, which is 18 plus 43, which is, let's see here, 61. And that's the result that we had gotten before by plugging 3 into G and then plugging that result into F. So you can either, if you're finding a number, plug it into one function, then plug it into the other, or you can find the formula and then plug in the number from there. Okay, before we move on from this example, I just want to find a formula for G of f of x instead. Okay. So let's look at G of f of x. Okay, so G of f of x, now we're plugging f of x into G. Okay, so we got to take the entire function of f of x, that's this right here, and plug it in for all the x's in G. So that's actually going to go in 2 places because x shows up twice in this formula. So this should be, so I'm just going to put parentheses squared for the x squared plus 5 times parentheses plus 10. And now I can plug anything I want in there. I can plug in x, I can plug in 10, I can plug in the entire function f of x. And so that's what I'm going to do. I'm going to plug in 2x minus 7 and 2x minus 7. Now notice this replaces the x. I'm not putting it next to the x. I'm replacing the x in the same way that if I was going to find g of 1, I would actually replace the x with 1. Well, now instead of replacing the x with 1, I'm replacing the x with a whole function. Now, I don't really want to multiply this whole thing out, but I will anyways. I think that's going to be 4x squared minus 28x plus 49 plus 10x minus 35 plus 10. And I could simplify that down to 4x squared minus 18x. 59 minus 35 is 14, I think. 49 minus 35 should be 14 plus 10 is 24. Okay, so I think that's actually 24. Okay, so there is a simplified formula for G of f of x. Okay, all right. So that's kind of how we deal with it algebraically. Numerically, I'm going to ask you to sort of figure out using tables. But I do want to look at graphs really quickly. So let's say we have a graph of f and g, 2 different functions. These are not the same functions as before. And let's say we wanted to find f of g of 2. Okay, well, this is pretty straightforward. Basically, you need to find g of 2 first. So I'm going to come over to this graph over here and notice that g of 2 is actually 0, right? That's the y value where the x value is 2. So I'm going to plug that in for g of 2 because g of 2 is equal to 0. And now I need to find f of 0. So I can come over to this graph. I can see that f of 0 is 0. So that gives me 0. Let's say I wanted to find g of f of negative 1. The first thing I need to do is find f of negative 1. So I'm going to come over here. F of negative 1 looks like it is 1 right there. And what's g of 1? Well, g of 1, it looks like is also 1. So I end up with 1. So basically, you can find the inner function value first by looking at the graph, finding the y value, then take that y value and plug it in to f. And again, we want to have this idea of, oh, you're going to have basically a value 2. You're going to plug that into g. Out is going to come g of 2. Then you're going to take that and plug it into f to get f of g of 2. So it's this sort of 2-step process, or it could be even more depending on how many functions you have. Okay, so hopefully that gives you a sense of how to compose functions. And we're going to now develop some skills with that and make sure we understand some of the scenarios that might use function composition. Okay, all right.